Okay, so let's look at chapter 1H, the number 5. And so the first question says, which of the 12 basic functions is not a continuous function? Now, the term continuous function is actually new. It means a function that's continuous on its domain, just the domain. Well, there are two functions that aren't continuous. So the two functions that aren't continuous are the greatest integer and the other one is the reciprocal function. Now remember, the reciprocal function is 1 over x. The place that this is not continuous is at 0. So it's discontinuous at x equals 0. But 0 is not in the domain. So this one, it's continuous everywhere that is in the domain. So this one is continuous on its domain. So this one is actually a continuous, it's called a continuous function. The greatest integer function, that domain is all real numbers. And it's discontinuous, so let me write this. Domain is all real numbers, and it's discontinuous at all integer values. So this one, because it's not continuous on the domain, is not a continuous function. So that would be the answer. Which four functions are odd? So remember, odd means a couple different things. An odd function means f of negative x is equal to negative f of x. And this also means, all these mean the same thing. It's symmetric about the origin. So the ones that are symmetric about the origin, that would be the identity function, which is y equals x. It'd be the cubic function, which is y equals x cubed. It would be, let's see, what else? The sine function, which is, well, sine of x. And what am I missing? Oh, the reciprocal function. 1 over x. Which 6 functions are always increasing? Well, okay. We've got the identity function. We've got the cubing function. We have the square root function. We have the exponential function. Let's see what else. We've got the natural log. And we've got the logistic function. Oh, geez, this is 1 over 1 plus e to the negative x. Logistic function. Which ones have no zeros, so they never cross the x-axis? Well, one of those is the reciprocal function. There's no way to ever get 0 out of this. Right? So there's one. One of them is the exponential function. That's always positive. And one of them is the logistic function. Which 4 functions don't have the end behavior where x gets really big, f of x gets really big? Okay, so one of those is going to be the reciprocal function. I'm just going to write this because that approaches 0 as x gets really big. One of them is going to be the logistic function, 1 over 1 plus e to the negative x. That approaches 1 as x gets really big. And we've also got sine x and cosine x, which always alternate between -1 and 1, even as it gets really big. So the y values can never get up to infinity. And then there's one function that has the property limit as x goes to 0 from the right, and f of x shoots down to -infinity. So that means if you're approaching the graph from this side, so approaching 0 from the right, the value of the function shoots down to -infinity. So there's only one graph that looks like that, and that graph is the natural log function.